last method that I would like you to be able to graph a quadratic with is called the DIVA method. Because depending on the chosen x values, you might not get a proper drawing of what we did yesterday, what we did this morning. A better method of graphing quadratics involves steps that can be remembered with the letters DIVA. This is a method that I invented, yeah, me. However, you're going to perform the steps DIAV instead. See how in real life people like to come up with little, what is it called? Is that like an acrostic poem or something when you come up with an acronym? But the problem is the maths has to be done in that order. But it's kind of snazzy if you call it DIVA, right? So, how do I graph quadratics with DIVA? I'm going to give you plenty of time to get these notes down. Firstly, write the quadratic in that form. Second, look at the coefficient of x squared. What is the coefficient? It's the number in front of x squared. If that number is positive, it's convex. So where is the curve pointing when this number is positive? Is it pointing down or is it pointing up? It's pointing down if that number is positive. If it's negative, it's pointing up. I'll give you some writing time. So writing time to here. Get that first. So that's what the D in DIVA stands for, direction. Do you have an iPad? As a starting teacher, I would highly recommend it. I'm not an Apple fan, but yeah, they've donated to bring your own device now. The PC alternative to these little apps are not very good. So literally the first letter of DIVA, D, it doesn't tell you how to draw it, but it tells you in your head what direction it should be pointing. Just get into your head the direction. I, standing for intercepts, that's where you start doing some maths. So I stands for intercepts. What you do, you make y equals 0 for your quadratic and solve for x using any strategy. The last couple of weeks, we've just been showing you how to solve a quadratic. The solutions for x are where the quadratic cuts or touches the x-axis. That's why it's called intercepts. If there's two solutions for x, then the quadratic cuts the x-axis twice. If there's one solution, then it touches the x-axis with the tip. If you get no real solutions for x, you can only draw the quadratic using a table of values in year 10 right now. Writing time, down to here. Get down to that star, please. I'll give you like 4 minutes for that because it's longer. It's one of my most watched views on my YouTube as well. People DIVA. It wouldn't have the same ring to it if I called it the DIV method. Yeah. So pretty much as soon as I've finished teaching here, as long as I don't stuff up and say someone's name, this will be uploaded to YouTube if you wanted to get a second go at it. So you'll notice when I record it, I avoid saying people's names. It's happened on occasion. They have a little laugh about it. But then before I upload, I'll get it onto iMovie or something and just mute it or cut out that whole bit. Eddie Wu style. Their laws in New South Wales are a little different because I know he says kids' names and stuff. And yeah, I wouldn't be allowed to get a media release fee. And yeah, one of the problems is when I do the stuff live, I like to be a little excited and not practice it. But that stuffed up last Friday because I didn't practice the question that I wanted to do. And I look like a whole smooth brain then. I fixed it though. I will show you on Wednesday. A couple of minutes and then I'll finish A and then V. And then you'll have a whole new way of graphing a quadratic that doesn't rely on luck. Also, if these steps don't quite make sense right now, that's perfectly fine. Because when you see the example and how it fits with this, then it becomes clear. It's like the mist disappearing from the valley. All right. A, what does A stand for? A stands for the axis of symmetry. Did I establish for you this morning that quadratics were symmetrical? Did you see that were the same on both sides? So the axis of symmetry lies where x is equal to negative b onto A. That's why you had to write the quadratic in that form so you can work out what negative b onto A is. Can you get step 3 down, please, which is about the axis of symmetry? You get that, writing time for that. When you work out what that x is, place a dotted line there vertically. That'll tell you where it's symmetrical. Just for the people that's a little faster, I'll scroll down to here so you can still see intercepts. The last step, V, stands for vertex. That's the fancy name for where the quadratic turns. So you just found x here using negative b onto A. Substitute that x back into your original quadratic equation to find y. The value of x using the value of y give you the coordinates of the turning point. So it tells you exactly where the little tip is going to go. So I'm going to give you writing time here. I want you to have those steps down so you can keep looking back at them and referring to it when we do our example together. So I'll give you like 3 minutes to get all those D, I, A, V down. And then you'll see how that works. The mist will disappear. Be different from the 11 essential class, isn't it? It's pretty different to mainstream, just in general. And the thing is, these guys only start to realise that when they hit year 10. And you got shared classes now, don't you? Yeah. They'll be like, some of the assignments in those classes are submitted. Some aren't. And I would place bets on who actually submits them in those mixed classes. A couple of minutes and then we'll do an example together. If you are looking to do more advanced maths, this technique will work all the way up until year 12. Hmm. 30 seconds and then we'll do the example. Remember, the video will be uploaded. Okay, we are going to practice drawing these two quadratics. I'm going to do the first one in blue, the second one in red. So A. What did the acronym spell? It was meant to be DIVA, but it doesn't work in that order. So what was the order? DIAV. D. What did D stand for? Who said distance? Don't name them. Direction. Shh. So I'm looking at the number in front of the x squared here. But there is no... Yes, there is. It's just not written. What number is it? 1. Is that positive or negative? Positive. So what direction is the curve going to point? It's going to point down? Look back. Down. It's going to be pointing... It's this one here. It's positive. So it's going to be pointing down. It's convex. So the working out... Shh, can you not argue, please? The way that you should write it is literally go that. If I draw this properly, it's going to have the curve pointing down. Next letter, I. This is the one that involves the most maths. Intercepts. So let me look at that step again. What does it say? Make y equals 0 for your quadratic and solve for x. You've been given a number of strategies. So I'm going to write this. X squared plus 2x take 3 equals 0. Common factors? No, because x isn't in 3. Is that a difference between two squares? No, because it's 3 terms. Is it a perfect square? No, 3 is not a square number. Let's try sum and product. What are the numbers I can times together to get 1 and 3? Is there a combination of positive and negative? Good. Negative 1 and 3. So that factorizes to x, take 1, x plus 3 equals 0. Is this a null factor law situation now? I'm timesing two things together, they equal 0. So, x take 1 could equal 0, or x plus 3 equals 0. So what's x going to be on the left? 1. Or, what did we say in the steps here? If there are two solutions to x, then the quadratic cuts the x-axis twice. Do I have two solutions here? So that's telling me the quadratic is going to go through at x is equal to 1. So I've got a dot there. Where else is it going to go through? So I'm going to put a dot there. See, the mist is clearing. I've got 2 bits of information in this quadratic. Can you see how I know that it has to be sort of this direction and it's going to cut the x-axis through those 2? I just don't know exactly where the little vertex is. So that's what the rest of this is for. What did the A stand for in our axis of symmetry? What was the equation for the axis of symmetry? X is equal to? Negative B on 2A. What is B in our quadratic? Which one? Is it 1? Is it 2? Is it negative 3? Good. So B... I want negative of it, so it's negative 2 on 2. What is A? 1. So that's going to be negative 2 on 2. What's negative 2 on 2? Good. So what is that saying? Let's look at the step again. The x value is the location of the axis of symmetry. Draw a dotted line up and down from here. Quadratics are symmetrical on either side. So that's like you putting a mirror down, and I'm the same on this side, and the same on that side. Where is the axis of symmetry at? X is equal to -1. So I'm going to put a dotted line up and down like that. Does that fit with the fact that these points are 2 away from each other? Like 2 away from there, 2 away from there? More? Mist is being revealed. So what is the last step? Vertex. Substitute the x that I just found back into the original equation. So vertex, what did I find? X was equal to -1. So I'm going to put that back into my quadratic. What was the quadratic? This. X squared plus 2x take 3. So I'm going to replace x with -1. So it's going to be -1 squared plus 2 times -1 take 3. What's -1 squared? What is -1 times -1? 1. What's 2 times by -1? Take 3. So what is 1 take 2? What's that right now? And what's -1 take 3? So what do I have here? I have x is equal to -1. Y is equal to -4. That's the coordinates of my vertex or turning point. So someone guide me, please. Where am I going to put the dot for the vertex if my x is -1? I'm starting at the origin. Where do I go? Left 1. And how far do I go, up or down?
Down 4.
Down 4. Excellent. Has it been revealed? Do I know where it's going to turn?
Yeah.
Do I know it's going to cut here and here?
Yeah.
Do I know that a quadratic is meant to be symmetrical on both sides? So here you can see me shaking again because it's all slippery. I'm going to try to draw this as smooth as possible. The only way you're going to lose marks drawing is if you draw that, okay? That's not curved, that's a V. We want it slightly curved, but we're not going to mark you down for being imperfect, okay? We just want to see that you're trying to make it curved and smooth. So that's all right. Did it go through the dots? We don't need you to get a microscope out and make it freaking perfect. You don't have time for that. The time was taken doing this. But can you see how the DIVA led to the drawing? I'll give you a solid 5 minutes to get that example down and we'll do the red one together.